Let's read this together. So this company manufactured this heavy-duty air compressors, okay, and they're trying to plan its production for the next 6 months. Okay, so that's their planning horizon. Because of seasonal fluctuations in utility and raw material cost, those unit costs of producing and the demand vary from time to time, from month to month, as you can see from this table here. And production capacity also varies from month to month due to differences in number of working days. So that's here, the maximum production capacity here show. Okay, and so this table summarizes all those 3 different things: that the unit production cost, units demanded, and the capacity in each of the months. Okay. Given the size of Yuptong's warehouse, a maximum of 6,000 units can be held in inventory at the end of any month. So maximum. The keyword here, maximum, that means we need some constraint here. Okay. The owner of the company likes to keep at least 1,500 units in inventory as safety stock to meet unexpected demand contingencies. To maintain a stable workforce, the company wants to produce no less than 1/2 of its maximum production capacity each month. Okay, no less than. Yuptong's controller estimates that the cost of carrying a unit inventory in any given month is approximately equal to 1.5% of the unit production cost. So that's the inventory cost. Yuptong estimates the number of units carried in inventory each month by averaging the beginning and ending inventory for each month. So that's telling us how to calculate this inventory, average inventory, and then the inventory cost. There are 2,750 units currently in the inventory, and they want to identify the production and inventory plan for the next 6 months that will meet the expected demand each month while minimizing production and inventory cost. Okay, so we went through this key information once. Okay, and let's think about, okay, what's the decision here? Or what do they want to do? So this is our decision, right? That's the decision. And the decision contains 2 parts: how many to produce and how many to put in the inventory. Okay. And what's the objective? Minimize the production and the inventory cost. Let me ask you, what's the relationship between production and the inventory and the demand? If you have beginning inventory, what happens? Let's see. Inventory, I'll use the I to represent it. Okay. Inventory, these 2 I are different. Okay. Inventory at the end of month I equals to be the beginning inventory, which means it's the inventory at the end of the previous month. Think about it again, right? Okay, so that's the inventory at the end of the previous month, plus whatever you produce that month, okay, right? Minus the demand of that month. Okay, And here we are saying this inventory is the end inventory. Okay, so that's the inventory at the end of month I is II. Okay, and production. Sorry, I defined it the other way. I should put II is this. So production in month I is defined as the PI, and demand in month I is this DI here. Good. So that's the relationship here. Okay, some initial analysis. That's me. So identify the production and inventory plan. So let's just define the decision variables first. Since our plan is to know how much to produce and how much to put in inventory. And we already know the demand. Based on that formula we just talked about, if we can calculate P from this OR model, do we know I? We know I, right? We cannot define both P and I as decision variables because there is a relationship between them. Is this clear? Because of that relationship, because here, let's go back to, because of this relationship, if my P is defined as the decision variables, then this I will be calculated depending on this formula here. Okay, because we know this I here, we know the D here, and then we know the beginning inventory at the very beginning. Okay, so once we define this as the decision variable, we will be able to calculate this inventory. But still, we're going to use a variable to represent this I because it makes it clear, make it easier to model. Okay, although it is not a decision variable, which means that when you implement this in Solver, you will only highlight the variables, the cells. You will only leave the cells blank for the decision variable which represents the P part. And the I's need to be in the formula like this. Okay, so the I equals to be the beginning inventory from the first month, and then when you calculate the inventory of the second month, then you refer to that there. Plus the decision variable cells, you refer to the decision variable cells minus the demand which are given. Okay, so those I's won't be decision variables. You won't leave them blank. Instead, you put a formula there. Okay, hope this is clear. Then here, so my decision variables will be just the PI. Represent the unit of air compressor, right? Compressors to produce in month I. Okay, so that's the only decision variable. Okay, but also we define II as the ending inventory in month I. So this is a variable that helps us to make the model simpler. Okay, but it's not a decision variable. That's why I just put it here. So this, I'm just put a parenthesis here. Okay, then let's look at the objective function. We know that we want to minimize the production and the inventory cost. Okay, so here I'm not writing the function yet. So we want to minimize total production plus inventory cost. Okay, so production cost is easy. It's the unit you produce, right? Because in that table, the unit production cost is given. Okay, so that would be PI multiply that's CPI. These are the unit cost, unit production cost. It goes from 1 to 6. Okay, and this part would be the inventory cost. And we do have the cost of inventory in the same table again. So here, we have here, they calculate the cost of inventory in any given month approximately 1.5% of the unit production cost. So that means we can calculate, we can maybe add a row here just to calculate the inventory cost being 1.5% multiply the row above being the inventory cost. Okay, the inventory unit cost. Okay, then what we need to pay attention here is that should we use the ending inventory or the beginning inventory or the average inventory when we calculate this inventory cost? So here you can see they estimate the number of units carried in inventory each month by averaging the beginning and ending inventory for each month. Okay, so that means to calculate this inventory cost, it's not the beginning or the ending inventory, should be the average inventory. That makes sense too, right? It depends on on average how many units is carried. Then where do we find this average inventory? So since we define this I as the ending inventory, and in this note here we already used this ending inventory and the beginning inventory. So here would be the beginning inventory of that month, right? Plus the ending inventory of that month. So this part is the average inventory. Okay, multiply that cost, and this cost is 1.5% of the production cost in that month. Okay, so with that, we got these two parts of our objective function. So I'm just going to go back to define here. So that would be a pretty big. If you want to define another variable just to represent the average inventory, so that the objective function is not that long, you can do the same. Okay, so for example, you can define. I'll show you the two ways. So here you define this and define INI as the average inventory in month I. Then in your objective function here, you don't have to write this out. You will just have this INI multiply this CII. So the objective function won't be that long. So either way works. Now let me go back to. So we want to minimize we'll write the production cost first. So that would be the 240 P1 plus 250 P2 plus 265 P3 plus 285 P4 plus 280 P5 plus 260 P6. So that's the production cost part. I'll put them in parentheses so just to differentiate. Plus, because the inventory cost is just 1.5% of the unit cost, I'll put this 1.5% out of this big parenthesis, so I don't have to write it for every month. Okay, so this multiply 240. I'll use the way I defined the average inventory. Okay, plus 250 IN2 plus basically the same coefficient as above, but just change the P to the IN, plus 285 IN4 plus 280 IN5 plus 260 IN6. Okay. And first thing what I'm going to do will be to define this IN. So IN1 equals to B. That's the average inventory in the first month. Okay. And we know that there are currently 2,750 inventory currently there. That means that's the beginning inventory. So that would be 2,750 plus I1. That's what we defined as the ending inventory. Okay, divided by 2. And after that, they will take the same format. I'll just use I to represent. Otherwise, we're going to write 6 formulas. Okay, 1 for each of the average inventory. But here I'll just use this I to represent it. Equals to be I minus 1. Or you can do this for all of them. Just define the first equals to be 2,750. But here we'll just do I divided by 2. For all I goes from 2. Yeah, if we want to apply to this one, we'll go from 1. Otherwise, we'll go to 2, 3, 2, 6. Okay. Or the other way to write this would be for this I equals to be 2 minus 1 plus I. For all I, that goes from 1 all the way to 6. And I0 equals to be 2,750. So either way works to define the average inventory right here. Okay, or the other way to write this entire thing would be, of course, we'll have other constraints. Okay, the other way would be to minimize. So the first parenthesis, I'm not going to write it. That's the production part, plus 1.5%. Then you write 240 times 2,750 plus I1 plus 250 times I1 plus I2 plus 265 times I2, I3 plus all the way to 260 times 2 I5 plus I6. Okay, so this part is exactly the same as what I wrote for this entire part. So it just depends on where you want to save some space. Say if you want your objective function to be not that long, then you use a variable to represent this average inventory and just define the average inventory using the variables you define. Okay, otherwise you just write this entire object function in this way. Clear? Okay, then besides those constraints, so if we use this way, first we need to define the average inventory being a relation of the ending inventory and the beginning inventory of that month. Okay, then continue. Let me just wipe those. Okay, so I'm going to leave just this part here. Formula here defines the relationship between your beginning inventory, ending inventory, production, and the demand. So that's another formula that we need to include in your constraints. Okay, without this, even though it does not say that okay, this have to be less than equal to something, greater than equal to something, this defines the relationship between your variables. Without this formula, the model won't solve. It's not regarded as like a constraint as the other ones, but still you have to put it here because this defines the variable relationship. It's kind of like, okay, the sum of your variables need to be something. Here, we have to write, okay, so, yeah, let's just use this way. We'll just use this as the constraint, and we will put this for all I goes from 1 to 6. Okay, and you will have to write out your D's because P is a decision variable, I is a variable, but D is not a variable. Okay, D are given, the D's are given. So D1 equals to be the unit demanded, 1000. D2 equals to be 4500. D3 equals to be 6000. D4 equals to be 5500. D5 equals to be 3500. And D6 equals to be 4000. Okay, so these two together define the second group of constraint, which is the relationship between your beginning and inventory and production demand. Now with those relationships defined, then we can go back to look at those other constraints. Okay, so we did use the unit cost, unit demanded we used, then the maximum demand production. So that's the capacity. So that means the PIs need to be less than or equal to those ones. You cannot produce more than the capacity of that month. Okay, so the third constraint. So this is the second one. Third constraint. Another big group. Okay, so P1 need to be less than or equal to 4000. P2 less than or equal to 3500. P3 less than or equal to 4000. P4 less than or equal to 4500. P5, P6. Okay, so that's the third group of constraint. Maximum production used. Okay. And then this one. A maximum of 6000 can be held inventory at the end of any month. So that's another constraint. That's for the ending inventory. So the ending inventory need to be less than or equal to 6000. The fourth group, I'll just use I to represent this instead of writing 6 constraint out. Okay, because the right hand side are the same. Right hand side are all less than or equal to 6000. That's for the inventory part. So that's for all I goes from 1 to 6. That's a fourth constraint. Okay, check. We to keep at least 1,500 unit inventory as safety stock. So besides this less than equal to, we also need a greater than equal to. The fifth one is I also need to be greater than equal to 1500 for all I. Now that's the next constraint here, 1,500. The company wants to produce no less than 1/2 of its maximum production capacity each month. Okay, just now we took care of this constraint. That's you don't produce more than these ones. And here they want to produce no less than half of those ones. So that means for all the P's, we have another side to write. That's half of. So all of these ones, I'm just going to add on this side. 2,000. What's this one? 1750. Okay, and this one, 2,000. This one, 2250. 2070. Okay, so that's constraint 3 and 4. So for the production, you need both sides to be there. And that took care of this constraint here. Okay, and we've already talked about this. That's calculating the inventory cost. Done. We use this value. Done. We did use this to define the decision variable and the objective. Okay. So that's the model for this problem. And the main thing for this problem is that when you calculate the inventory cost, they use this average inventory. Okay. But when you need to define the relationship between the production demand, you need to use the ending inventory. Some students confuse those together. So they use one variable here, just this I, and when they do the inventory cost, they just use the I instead of the average inventory. So that's one place to be cautious about. And the other thing is that since in the objective function we use average inventory, some students started with define the average inventory as the direct variable to be used. And they use this IN here as the variable. And when they try to define this relationship here, they try to use this IN, which is the average inventory, and don't know how to formulate this relationship. Okay, so you see it's more straightforward to define these I first being the ending inventory and use those I to calculate the average inventory, instead of defining the average inventory first and try to calculate the ending inventory, because there's no way to calculate the ending inventory from the average inventory. So the relationship the other way. Think if it makes sense. Okay, so if we start with this I here, the beginning ending inventory, it's very easy to get the average inventory. But you start from average inventory, try to represent those ending inventory using the average inventory you defined. There is no way to do that. Okay, so that's the things that need to be taken care of. And in this problem, because the P's already have its lower bound, so the decision variables, usually we need to add a non-negativity constraint for our decision variables, right? But in this case, all the decision variables have lower bounds, greater than or equal to 0. So we don't need that non-negativity constraint in this case. So that's our model. Okay, and so in the slide, I defined, I used the B to represent the beginning inventory. Slightly different as what we talk about, so yet another way to define that. And so instead of using I minus 1 and I, here the inventory is defined as the beginning inventory, so it's kind of like I and I plus 1 here. because the B is represented the beginning inventory, and in the model we just defined is the end inventory. Okay, so it's like BI plus BI plus 1 being the average inventory. Inventory in month I. Okay, and use the long objective function. And those values are already calculated using the 1.5% multiply those rate. And the production level already talk about them. The capacity and the half of the capacity in each month. And the inventory, instead of using the I replace that inventory using the actual formula here. So let me go back. So what I wrote here is equal to, just say 1500 less than equal to B2 less than equal to 6. And B2 equals to B1 plus P1 minus 1000. So these two together can replace this formula here. Okay, make sense? But this way is easier because you don't put a lot of the formula in your constraint itself. Okay, you just put this on one variable here and define what that variable is. And the other constraint, yeah, here, that's it. You define the other constraint.